Hello, mentors. So this is meeting 6. This video, let's take a look at all the student workbook for part 1, that is, and look at all the challenges or the missions that we have in all this sequence of activities. So page 1 is just the stacks games, the rules, the basic rules, but the LAs will do a job of explaining this in the beginning of the meeting. So this slide 1 or this page 1 of the student workbook hopefully doesn't take much time. So we have a dedicated maybe 5-minute tops for warm up, just in case kids want to play a little more. But you should very quickly go to the next page, which is page 2. And there's another video that explains the rules of the game. So I'm assuming when you're watching this video that you already know how to play the game very well. So now we start with challenging. So your table, let's say you have 8 students or so, you could divide it into 3 teams, like mini teams of maybe 2-3 students each. And each team will work on challenges and get points. Of course, the teams can interact, and of course they can help each other here and there. So it depends on the dynamics of your table, how they want to really compete, or how they want to maybe help each other gain a point and say, hey, I discovered this way of doing it, so I'll trade you this information for that other information. So that's totally fine, and it depends to you. Anyway, so here are the challenges in page 1. We start with 4 different challenges. The first one is you start with a cup, any cup, and then you have to play starting with that cup. So for example, if you play the middle cup, you have to start the game moving the middle cup. Can you win this game? If you do it, you win 2 points. And since there's 5 cups, 5 times 2 is equal to 10. So of course, this challenge has 10 possible points. So for example, if a team in the first challenge only did 4 out of 5 of these missions, let's say they couldn't really complete the middle, then they'll get 8 points. That would be an example. The second challenge is very similar, but instead of picking where to start, it's where to end. So let's say I mark this post-it with an X, or maybe put a small coin or whichever marker, and then I play however I want, but I want to end in this post-it note in this space. So students will realize, for example, that they cannot really move this cup because otherwise the space would be empty. And all these mathematical features they could explore. They could also know that if they know how to win with this ending in this spot, then by kind of reversing the game, they can also win here. So there's a symmetry property. Again, you can win up to 10 points. Maybe here the team didn't get too well, so they only got 6 points. So that's fine. The next is this on top, please. So they'll choose a cup, which in essence it's picking a color because they'll have 5 cups with different colors, hopefully. So maybe this is a yellow cup, I don't know, and they say, okay, I picked the yellow cup. And so the game is, can you win finishing so that the cup ends at the top? That's what you want to do. So is it true that for any cup that you select, it's possible to win with that cup on top? It doesn't say that you have to start with that cup, so you can reserve this for future moves, but that's for students to realize, right? So the less you tell them and the more they discover, the more fun they'll get. Again, this is up to 10 points. Maybe students here got really good and actually won 5 out of 5, so 10 points. And this last is the most challenging of this page, as far as possible. It's called, you pick any 2 colors or any 2 cups out of these 5, and then you want them like in a sandwich. So you want to finish so that these 2 colors form the endpoints of that stack in any order, the top and the bottom. For example, you pick a yellow and a green, so you want the yellow and the green to be top bottom or bottom and top. We'll get 1 point for each because there's actually 10 possibilities of picking 2 colors without any order from a set of 5 colors. And so here, let's say students got so maybe 7 out of 10. So, I mean, that's good. Here we don't multiply by 2, we just get 7. And here students can mentally add or just put here the number. So here they would have, 18, 24, and 31 points. So not too bad. So they could write it here with their pencils. That's how they are doing right now. That's page 1. You can speed up in some of these challenges. Hopefully your LAs will say, but hopefully there's a big competition between all the teams of all tables. So that'll be like lots of teams, because if your room has 5 tables and maybe there's 3 teams per table, so it's 15 mini teams competing. But here's what gets interesting is the next challenge is a whole table challenge. So these award points for all tables, or 50 points, or maybe just 0 points if the teams don't really complete it. Here's the challenge. You start with 9 cups, so you go really high now. So there's hopefully a lot of curiosity what happens, and it's going to be overwhelming maybe at the beginning. Wow, how can we keep track of our things? And then the goal is to end in the middle, to end with the stack right in the middle. You can see the solutions in the teaching guide on how to play this game, but hopefully you try on your app or on your physical cups before. You play with just one set, so you play at the center, and hopefully the idea is you take turns clockwise. So each turn a player either suggests a move or actually makes a move, but there's a lot of discussion on why are you doing this. A turn could be also asking a question. So I think what's important is that the student participates either with a question or with a suggestion or with an actual move that the student moves. It's gonna be challenging for mentors, of course, that no students get disengaged, that all students are playing together. So that's certainly something that you can keep your eyes on. And you have a help, so you have one undo for the last move if some students forecast that it's not really gonna be a winning move for the game. You can play a game for 10 extra points, but change the end goal, so the position you want. So for example, your students could say, okay, let's try to land here, or let's try to land in the beginning, right? In the first of the cups, and just play. So actually this is doable and it's very fun. Again, you could always play if your table, really likes challenges, you could play with even 11 cups or 15 cups or so. And if you really have a method, then it's going to be fine. Of course, give more help there. Maybe not just one undo, but 2 undos. Okay. And award points accordingly. Bear in mind that this is a whole room competition, hopefully. So don't go past 60 points here. Hopefully, maybe 70 tops. So talk to your LAs on that during the meeting. The next challenge, it's not really a part of the competition. So here the points are awarded, and I think that'd be all for the end. But then this is how to extend this game to 6, 7, 8, a lot of cups. And the idea is it true that no matter how many cups we start with, maybe 10, 50, or even 100, 1,000, doesn't matter. We can always win the game, but not only that, but end in any position we want. So for example, if you play with 200 cups, can you win with ending in the post-it number 3? That looks like very, very demanding, very challenging, but you can actually do it. So this game is very rewarding. This game is very flexible, and it just works well. It's like a clock, so it never messes up somehow. It always gets the things right, as long as you don't do many crazy things. I think that's the main takeaway that you'll get from playing this all over. So here students will just hopefully say a lot of yes here, that they could win the game ending in all these positions for the 6 cups. And then there's some recursion argument. You can take a look at the solutions on how to explore this part. I think you would be happy if students not only conquered maybe the case n equals to 7, but they see that they can conquer it by playing mini games, sub games, right? So smaller games for 3 cups and 4 cups or something like that. What else? Well, if you're still hungry and your students are still hungry, they want to still get challenged, and hopefully you reserve some time, you go 2D. So you play the 2D game. The rules are similar. You can also play it in the app, where you would go to 2D and play these type of versions, where cups are also moving, same as before. So very similar. Okay, here I think I lost. So they just play and they just try to compare does this game feel different or feel kind of the same compared to the game that I just played? Okay, so I'm losing every game. Now, this is more free, so we don't have many like closed questions, but maybe conquer it in the sense that we can win the game with 2 rows and many cups. I think that would be the exploration. And there's a very nice video showing a pattern for this. And can you go beyond this, even adding more rows? And finally, the last challenge is also a whole table challenge that could be a good closure, either from your LAs or from tables. That is, you have this A and this G here, and you're playing the n=7 version. So you label A and G. And you want to end like in a sandwich type of thing with A on top and G on the bottom. This you could extend, of course, to another level. So this should feel similar to 5, but now your students may have more tools or more resources to kind of guide the game in a more general way, not just random, not just maybe trial and error, but actually see patterns and anticipate, I need to do this, I need to do that. Think about mini games where this or that happen. And this has also a very nice recursion to it, because you essentially maybe like you want to end in G, right? So if you are able to all these cups before G, place them end here with A on top, then how many cups are here? 1, 2, 3, 4, 5, 6 here, and then you fly 1, 2, 3, 4, 5, 6. You exactly land in G. So now you have yourself a mini game. Forget about G for now. That's kind of the induction, right? The recursion. My new game is with just 6 cups to end in A. But then you do the same. If I could somehow these 5 cups put them in only this place, then I could move them. I could move them there. Something like that. I think there's some more arguments to be said, but you get smaller and smaller games. Yeah. So those are the challenges. Yeah, I think they're what I said. You still would need A to be on top. So actually, yeah, let me backtrack. I want these 5 somehow to collapse to this spot so that I move 5. I move A here, and then I would win. So it just becomes like a accordion in which you have smaller segments. So you start playing these smaller games, and then you win, 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 win. So it becomes like a domino effect. So it's a little challenging how to get this across, but it's a negotiation between what your students are seeing and you pushing your students. It's not just explaining at the beginning, but it's actually having kids pay an effort on how to relate complicated games with simpler games. So that's what it's all about. Try to go in order, but you can skip some steps. So if maybe you don't have much time here, you can skip some of the parts and try to see what piques your students' attention more. Okay, have a lot of fun and see you in a next video.